Welcome back, Night Owls. This is Dr. Nighttime, and tonight we're driving the Victorians crazy and getting improper. We're going to integrate improper integrals, but we're going to make sure to do it properly. So, let's start with this harmless-looking integral. Integral from -4 to 2 of 1 over x squared dx. Alright, harmless-looking enough. We can just do the reverse power rule, raise the power by 1 from -2 to -1, divide by the new power, so divide by -1, we'll get -1 over x. Okay. Antiderivative of 1 over x squared is -1 over x. Easy enough. We evaluate that between -4 and 2, or so lower bound -4, upper bound 2. So, for our upper bound, we plug in 2, -1/2, right? -1 over 2 is -1/2. For the lower bound, we get a positive 1 over 4. We add those together, and we get that this integral is just -1/4. Yay! Wait a minute. Something doesn't add up about this. The function, 1 over x squared, is a strictly positive function, right? You plug in any value of x, you're not going to get a negative number for that. And so when you integrate a positive function over a forward-facing interval where the lower bound truly is lower than the upper bound, you should get a positive number. Why are we getting a negative number? Because we kind of cheated here. We tried to just integrate, ignoring the fact that there's a vertical asymptote. Remember way back in your first couple days or week of calculus class, I said, find the domain restrictions on the following function. Blah, 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 blah. Well, now we actually need to use it briefly. We have to realize that the function 1 over x squared doesn't exist when x equals 0. So we can't integrate across the asymptote. So we have to break it into 2 integrals. Okay, we can't cross the line. Integral from -4 to 2 of 1 over x squared is integral from -4 to 0 of 1 over x squared, plus integral from 0 to 2 of 1 over x squared. Fine. So that means I have -1 over x from -4 to 0, plus -1 over x from 0 to 2. Okay, I plug in my bounds, I get a -1 over 0. It doesn't look so good, but -1 over 0, -1 over 4, -1 over 2, plus 1 over 0. I'm subtracting a -1 over 0. I can cancel my -1 over 0 and positive 1 over 0s and get -3 over 4. Why is it still negative? Gee, so we look. Which of these steps seems like it might have been something we weren't allowed to do? Yeah, it's saying 1 over 0 minus 1 over 0 just cancels. You can't just subtract undefined functions or undefined terms and claim, yeah, this is just going to cancel. It doesn't quite work that way. There's one more subtlety we need to worry about. We actually have to use limits. What we'll say is we'll assume that epsilon approaches 0 from the positive side. So epsilon is always some number slightly more than 0. What we can say is that this integral from -4 to 2 of 1 over x squared is the limit of small positive epsilon. We're not going to quite cross the line. We'll go from -4 to negative epsilon in our first integral. And then from positive epsilon to 2. And do everything else the same way we would before, right? Limit as epsilon goes to 0 from the positive side, -1 over x from -4 to negative epsilon, and then from epsilon to 2. And now when we do that, we notice we get a -1 over negative epsilon, minus 1 over 4, minus 1 over 2, plus 1 over epsilon. Now is where we realize that this -1 over negative epsilon, for positive values of epsilon, this becomes a positive large number. We add that to another positive large number. That limit is going to infinity. And just taking a look back at the previous slide, when we tried to say -1 over 0 and 1 over 0 and just cancel those out, it turns out this 0 is actually always going to be a little bit less than 0, right? We can view 0 is either a tiny little positive number or a tiny little negative number. Because we're stopping the integral just before the asymptote, so that we don't cross it, this 0 is going to be a tiny negative, this is going to be a tiny positive. That's why they actually add up rather than canceling. And so that's why they make you go through these improper integrals, and why whenever you're integrating something that has a vertical asymptote in it, you have to stop just short of the vertical asymptote and start up again just after the vertical asymptote, and make sure that in your limit of taking tinier and tinier gaps, that nothing bad is happening, that you're in that limit, that you're actually converging to a number. Or if it's going infinite, you'll have to say so. Hope you found this useful. Short video today. But as always, if you like the way I explain things and want to arrange private lessons, click the link in the description. And until next time, this is Dr. Nighttime wishing you a good night.